Hey everybody. It's Cosmic here with Astronomy Daily Live. I'm about a half an hour late. I've been having some power dropout problems. I don't even know how long this is going to last. For some reason, and even now, my light is flickering. It's only on this circuit. And it's actually the circuit that is running uh, these machines, and it's also running the computer outside where I was going to be doing some observations tonight, but I've had like 4 or 5 dropouts. I've tried to take flats. My flats are completely just totally junk. So my observing for tonight is screwed. Um, this hangout, I don't know how long this is going to last at all. Don't have a clue. Um, so yeah, it's one of those things. It's frustrating though, very frustrating. So hey, glad you could come in. Um, yeah, having some power problems tonight. Just all of a sudden, um, just on like this, it seems like um, just this one circuit, it just flickers out. And even now, the light that I have attached to this circuit is flickering on and off. And so who knows how long this is going to last? It's completely screwed my observing run for tonight. Um, I don't know. I'm going to have to find a different, more reliable power source because this is unacceptable, totally unacceptable. So yeah, I don't know how long this is going to last. Maybe this will just be a short Astronomy Daily Live. Um, so I'm going to try to uh, get things lined up here. I've had to, I mean, computers don't like to just be shut down, power cut off uh, like that. So these poor machines are having fits. I'm having fits. Erg. Let's see. Having problems with connecting to the network on my Linux machine. For some reason, yeah, it's probably the same circuit that my router is on. So my router is probably going off every single time it flicks power, and so it has to refine things. And yeah, it's just causing a little bit of havoc havoc here, and that makes me not think about astronomy, which sucks, which totally sucks. So yeah, trying to get on here. Let's see if I was on the Discord earlier on the laptop here. Laptop seems, so the Wi-Fi seems to be okay, but my wired connection is not connecting. Let me make sure that my connection is okay in the back. Hold on one sec. Yeah, that seems to be okay. Yeah, who knows? You gotta deal with these stupid, silly technical problems. And yeah, if I understood what was going on with this dumb thing, I well, I wouldn't. I mean, what's most upsetting is that it it completely ruined my observing run. Got to be able to take flats. If I can't take flats, then there's absolutely no point in doing any kind of observations because I have to be able to, reduce this data down. So I'm just looking at, starlight. Can't be looking at, differences in gain. Can't be looking at the electronic noise, all of that. So yeah, and for some reason my Linux machine is not coming up here at all. So I guess what I'm going to try to do is go over here to my YouTube on the laptop and see if I got that way. Yeah, just frustrating. Frustrating. And yeah, the power could basically go off again at any moment. And so yeah, just just a frustration, just one of those many frustrations in life. And it's a little weird. It's a little weird. I'm not quite sure. It seems to be coincidental with um, starting up this laptop. Maybe this laptop's pulling a lot of extra power. Um, yeah, I don't know. I think what I'm going to do is I'll try to put this laptop on a different circuit and uh, and see what happens. The thing is that it won't. It'll be just fine. It'll be just fine for the next 24 and a half hours, right? It'll be just fine, or the next 23 hours, you know 55 minutes. It'll work just fine, and then I'll want to try to start the live stream, or I'll try to want to observe. So, I'm going to have to wait now until tomorrow night to do any observing. And, tonight was nice and clear. There was a little bit of wind still, but I think the wind was going to die down. It usually does um, after the sun sets. Um, So, the only thing that I would have to contend with is the moon. And for what I'm doing, that's not a huge, huge, huge deal. Um, so yeah, just frustrating, frustrating. And my poor Linux machine here is just not. I'm gonna try just rebooting it, restarting it, and seeing if that does anything there. So, well, I hope wherever you are, things are going a little bit better. I think what I want to do, um, let's uh, let's look quickly over at archive.org and see what the bleeding edge. Oh, come on! What the bleeding edge of astronomy has. Let's sort of get into the astro mode here a little bit more. Get out of the power problems mode and go over to archive and see what the latest and greatest research in astronomy is is all about. Let's see if it's updated for Thursday. Ah, it is. Yay. So they update these every weekday at somewhere around like 1 hour UTC or so. That's sort of what I've noticed. And these are just the latest papers, in this case astronomical, that have been accepted for publication. Probably not yet in print yet, but these are called preprints. So yeah, and as I said, just as a warning again, I could lose power, I guess, at any moment here. And when I lose power on this laptop, the live stream goes away as well. So hang with me, but yeah, you never know. I'll try to figure out what's going on, but yeah, when this starts affecting my ability to not only do these live streams, but also um, compound that with the fact that it completely screwed my observation plans tonight. Yeah, something must be done. Something must be done. So let's see. Yeah, I heard about this galaxy lacking dark matter, and you know, I'm not I'm not too keen on dark matter, but so a galaxy that doesn't have any dark matter, well, that I don't know, that sort of makes sense to me, but depends on your perspective. So yeah, but I heard a little bit of news about that, just the headline. Um, let's see, studies of galaxy surveys in the context of cold dark matter paradigm have shown the mass of the dark matter halo and the total stellar mass are coupled through a function that varies smoothly with mass. So their average ratio has a minimum of about 30 for galaxies with stellar masses near that of the Milky Way. Uh, and increases both scatter in this section. Okay, but for this galaxy, um, where does it give a ratio? This implies that the ratio is of order unity, at least a factor of 400 lower than expected. So yeah, something interesting is going on there. Who knows? Who knows? I'm gonna assume that my smartphone is connected. Looks like it is. Looks like the live stream is going. Oh no, that's the old one. Let's see if the current one is. Yeah, the current one is going too. There it is. Do that so I can't hear myself. And let's see, do we have connectivity? Oh, wired connected. So my Linux machine has now decided to connect. I'm just wondering if, maybe I'm just pulling too much power from one circuit. That this, because the coincidence between turning on this laptop and the power going out is just a little funky for for me. So I'm just wondering if I'm just pulling for, I mean, it's a 15 amp breaker. I don't know. I don't know. Anyway, I will put this laptop on a different circuit tomorrow. And in fact, I might even try it tonight since I still have my telescope and camera and everything else outside still. Maybe I'll do some testing with that. Use them as guinea pigs. So galaxy lacking dark matter. Yeah, just let's see. Pretty interesting. Let's see what else we got here. Yeah, I think this is going to be a short Astronomy Daily Live because I'm just uh, frustrated. Close relationship between Lyman alpha and magnesium 2 in green pea galaxies. Green pea galaxies, I remember hearing something about green pea galaxies. Don't remember what those are. This thing still isn't. It says it's connected, but that's not coming up. That's not coming up. Let's see if I can ping to the outside world. Nope. All right. So there's an interesting title to a paper, Understanding the Galaxy. A general overview of understanding our galaxy is presented following the lines of its main structures, halo, disk, bulge, or bar. This review is emphasizing some time domain astronomy contributions. On the one hand, let's go into this here. On the one hand, the distance and tangential motion of the stars are essential to this understanding and are obtained through multi-epoch surveys. And on the other hand, the chemistry of the stars and their radial velocity are also key elements to map galactic substructures and unravel their history and evolution. Contemporary surveys are revolutionizing our view of the Milky Way and galaxies in general. Among these, the Gaia mission excels by its precision astrometry of 1.3 billion stars stretching through the Milky Way and beyond, providing the first 3D view of a major part of the Milky Way. So, yeah, there's what about 500 billion stars? So, 1.3 billion is what is that? I'm going to pull out my handy dandy calculator here and take 1.3 and divide it by 500. That's uh, that's 0.26% of the population of the galaxy. Now, do we really think that we have a good understanding of the galaxy when we only sort of know about 1.3 or 0.26%? It's a quarter of a percent of at least the observable stuff. I don't know. I don't know. That's to me that's sort of a red flag when it comes to the skeptic in me, because it's like, yeah, that is a lot of stars, but yeah, I don't know. I don't know if that's a good enough number or not. Given the fact that there are 500 billion. Um, yeah, I don't know. I don't know. You know, statistically, if that's enough to be able to say yes, we have a good handle on these things or not. I don't know. I would sort of lean towards saying that we don't really have a good handle on these things. Not quite yet, but what do I know? Gamma ray bursts. Don't get any good satisfaction here. We'll do an object of the day, and then we'll call it. Let's see if let's see. Is there a chat somewhere in here? Oh, there is. Uncle Bill. Uncle Bill. Yeah, Uncle Bill. I'm not quite sure because I think I can't be exactly sure. Um, I may not have replaced this breakers in quite a while, but it's not that it's tripping, right? I mean, it powers off for about a tenth of a second. It just flickers, and I don't know if that's how breakers behave when they trip, or I mean, my experience with that is that if it thinks it's seeing too much power, then it trips and it stays off, right? This is not staying off, it's just flickering. So frustrating. And yeah, my Linux machine can't connect to the network, so that's just ah periodic configuration of the Kepler 25 planetary system. Mouse Pulsar Wind Nebula. Huh. Let's look at that. That seems a little interesting. I've never heard of the Mouse Pulsar. So these are really great because you can just sort of pull up the papers for free and take a look. Slow network. Oh, poor network. See, I've got the power off to my computer and camera outside, and I'm not seeing any more flickering or anything else. So it's an energetic supersonic pulsar. So it powers the Mouse Pulsar Wind Nebula, which consists of a pulsar tail spanning 12 arc minutes in radio and 45 arc seconds in X-ray. So they use Chandra, which is a observatory in orbit around the Earth, so they can see X-rays out there. We can't see X-ray sources from the ground because our atmosphere absorbs them all, absorbs them or scatters them, reflects them. It's probably a reflection, I guess. Um, Pulsar and its X-ray nebula, as well as an analysis of the archival low-frequency data. Well, let's see if there's. Oh, sorry. If there's some, see if there's some pictures. I always like to see pictures. So there's the pulsar parameters. Spin period 98.8 milliseconds. So that's pretty fast. 98.8 milliseconds. Let's see, that's 98.8 divided by 1,000. So that's 10 hertz. It's spinning 10 times a second. Spin down power, just insane numbers. Surface magnetic field, okay, 2.5 times 10 to the 12th Gauss. It's just insane. Spatial morphology. Merged image from 5 ACES observations with a pixel size of 1/4 of an arcsecond. Smooth Gaussian kernel, zoomed in. White arrows showed the direction of the pulsar's proper motion. So it looks like it's moving due east relative to us. That's kind of strange and interesting. Okay, so that's just a brightness profile. Okay, just they're just doing a profile across here, right? So it's dark over here, and then it gets brighter, 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 really fast, and it peaks, and then it slowly drifts off, just like it's shown here. Yeah, pretty cool. I have to read this up a little bit more to really understand what they're going after and what they're trying to understand and what information they're using to derive that knowledge. But yeah, pretty interesting. Yeah, this is getting into some pretty heavy, deep stuff. Let's do a object of the day, huh? Let's round off this rather ruckusy, ruckusy uh, chapter of Astronomy Daily Live by looking at a Messier object, which we can be pretty sure is numbered between 1 and 110, and that it actually exists. Unlike last night's one, NGC 2707, yeah, the non-existent NGC object. That's crazy. All right, so I'm going to have random.org choose a random integer between 1 and 110. There are 110 Messier objects up in the sky, and so let's focus on one, and then we'll call it a short night tonight. M21. Oh, M21. Which one is M21? Oh man, M21. Man, I cannot remember which one this is. Not for the life of me remember which one this is. That's awful. I call myself an astronomer and I don't know where or what M21 is. Ah, for shame. For shame. So we're going to cheat and look it up. Open cluster. Open cluster. Oh, sort of near the galactic center. Yeah. It's got equatorial coordinates, right ascension and declination here. So right ascension is 1804.13, 18 hours, 4 minutes, 13 seconds, which puts it right along the Milky Way. And negative 22 degrees, 29 minutes, 24 seconds. That puts us that puts it pretty close to the center of the galaxy. Pretty darn close. Pretty close. See, they have actually galactic coordinates here. So uh, um, the galactic longitude is 7.6 degrees. So it's 7.6 degrees um, east of the center of the galaxy along the galactic equator. And yeah, look, the galactic latitude is a negative 0.354 degrees. So it is right on the galactic equator and only 7.6 degrees east of the galactic center. So yeah, this is really close to um, the center of the galaxy. Of course, it's just between us and the center of the galaxy. It actually isn't, physically uh, at the center. And it looks like it's moving towards us, about 14.71 kilometers per second. So it's trucking along. It's pretty big, 14 arc minutes all the way around. All of its different names. Does it have an NGC number? Oh, it does. NGC 6531. So doesn't look like it's been studied a lot, but there's a few papers that apparently talk about it. So this is where we get into the distance, right? So I think we're about 30,000 light years from the center of our galaxy. So let's just see how far away this cluster is. So this is saying 1,205 parsecs. Parsec is 3.26 light years times 1205. So that's about 4,000 light years. So it's a tenth of the way towards the center of our galaxy. So not really even close to the center. It just seems that way because, line of sight. Let's see. What does Ned have anything more interesting about this? Still trying to get my my poor. It says wired connected. That's really strange. It says that it's connected, but for some reason I'm not able to get out. Just try this again here. See if it connects. It's Messier 21. I didn't see anywhere where it got any information on. There we go. All right, I'm connected with my Linux machine now. Now I can be dangerous. I didn't see anywhere where it gave a number of stars in the how many stars are part of this cluster. Let's see if we can try to find that out. Sometimes that's nice to know. Okay, I am reconnected on my Linux machine. Yay. So now I can actually watch the chat a little better. Yeah, I don't know if it's a loose connection. Don't know, Uncle Bill. It seems to coincide with the turning on of this laptop. So yeah, I don't know. We're gonna have to look into that a little bit more. Just frustrating. That's all. And it's a common thing. I would really like to. I'd like to see if we can find out how many stars they think are part of this cluster. So I'm not seeing that information anywhere. Distance. There's all the references, which we can get into. I'd like to get a population count, Well, let's look at the references and see what's going on. And as I said, I think I'm going to keep this live stream a little short tonight. Not go the entire hour, but basically stick to the same schedule and get out of here a little bit after 3 hours UTC, regardless of when I start. frustrating as it is. Let's see if there's any just basic papers on shape parameters, orbits of open clusters in the galaxy. That's pretty cool. Blue blue stragglers. Blue stragglers are pretty interesting little stars. Evolutionary status of BE stars. Deep sky delights. Yeah, I'm not seeing much of anything there. Let's just, obviously this is an open cluster, so this is a cluster of stars that are all moving together, which implies at least that they are, gravitationally bound to one another, or at least formed at the same time and are moving through space more or less the same way. It's not a very rich cluster of stars. Looks like just a few here. Maybe extends out. It's really really hard to tell. You can't tell just by looking at a picture like this. Which star is going to be part of the cluster and which star isn't, especially in such a rich field like this, where there's a lot of stars. Right, we're looking towards the center of the galaxy, and so there's just a lot of stars. But you know, there are. It looks to me that there's this group of stars here that sort of are the same color, the same brightness, same general area. So I'm thinking that, maybe a lot of these, don't do that, that a lot of these bluish stars here might be, no, 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 might, might be a part of it. Um, hard to tell. As I said, this cluster, um, they measured it to be what only like 3,000 light years away, while everything behind this is 10,000, 20,000, 30,000 light years away. So yeah, it's very much a foreground object for sure, but it's it's a pretty one. And again, I sort of wonder, how Charles Messier confused this with a comet, because you have very very distinct stars that even back then, he was observing these in the 1750s. So and uh, technology obviously wasn't as good as it is now. Um, but did he see this as a fuzzy thing that looked like a comet? I don't know. I don't know. I'm sort of thinking that maybe it's a combination of the optics of his telescope probably wasn't obviously as good as they are now. But I'm sort of thinking that maybe he was biased as well because he was a comet hunter and looking for comets. Sort of everything looked like a comet, which is just this faint fuzzball. So even if it didn't, actually look like a comet, maybe he was seeing it sort of the way that he wanted to see it. I don't know. I don't know. Because, I mean, I can sort of understand if, when he looked at like M13, right? A great globular cluster up in Hercules. I can understand how he could see that as a faint, fuzzy object and being able to pick out individual stars, right? But something like this, M21, where you have very distinct stars that are spread over a pretty wide area. Um, I'm not quite sure how he was seeing. He was thinking that this was some kind of strange comet that didn't move. So I don't know. I don't know. It's impossible, to read people's minds. Um, I would like to see, and this is probably something that I can do. We can actually probably find his notes, his observing notes, and actually see, you know, try to understand what he saw when he observed these. So yeah, maybe I'll try to do that, because that's been a mystery to me for quite a while. So, all right, hey, I think I'm going to exit exit this for now. Wanted to give a shout out to cloudynights.com. I'm really, really enjoying it over there. I signed up for it almost a month ago, and I forgot about it until just a few days ago. It's a very, very active um, forum, and subjects on every kind of astronomical thing you can possibly imagine, and a very, very active membership, and some pretty smart people over there too, for sure. So check them out, cloudynights.com, and yeah, all right. I think I think I'm gonna stop sharing, and I don't like to share anyway. And I think I'm gonna get out of here for now. I'm gonna go do some experiments with power, because look, this thing has been running just fine. My light has not been flickering at all, because the computer outside and the system outside is not on right now. I've turned it off, so I'm gonna go turn it back on, and probably turn off. Well, no, if I turn off these machines, then it's not gonna tax the system. I don't know. I don't wanna use these machines necessarily as guinea pigs for this kind of an experiment. So I'm thinking what I'm going to do is I'm just going to um, put this laptop on a different circuit, and see if the problem goes away. Um, because yeah, there does seem to be a coincidence with using the observing computer outside and running this at the same time. So maybe something will have to be done about that. Um, Maybe I won't be able to do observing and the live stream at the same time. Okay, well, we'll see how it goes. For now, I think I'm going to exit, and um, deep apologies for not getting on at the appointed time. I had made a little sign saying, that I'd be back, no later than a certain time, and then the power went out again while I was trying, to take my flats, and yeah, that's just how it goes sometimes. Just frustrating, very, very frustrating. So, all right, I'm gonna get out of here for now. Peace. Cheers. Take a couple of deep breaths, and I will definitely, one way or another, be with you again tomorrow in a little less than 23 hours from now. One more, one more rotation all the way around this tiny, tiny little planet. All right, I'm gonna get out of here for now. Peace and cheers. See you tomorrow. Bye.